you're presenting in a group wise, so you have to practice a lot so that each member can give a presentation of 2.5 minutes, so that you'll end up exactly in 15 minutes, or just less than that, or slightly more than that. Not like I have seen some groups have taken like more than 20 minutes, so that is a negative thing. Okay, and some deduction, marks reduction may happen. Okay, so be specific, practice a lot. First, I think first is collect your materials. Okay, because from the material point of view, your presentation should looks good. Okay, so material should be in terms of quality of data. Okay,
Okay, sir.
and the topic I have already given to you. You choose. Besides that, you can choose your own, but it should be an environmental issues. Okay, clear, students.
Yes, sir.
Okay, good. Okay, so let's go to the presentation.
Sir, today we'll have any quiz.
Yes, yes, we'll go for quiz. Quiz is for every classes. Okay. All of you can see the presentation.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So in last class we discussed up to this albedo effect, or it is the Earth's capability of reflection capability. Okay. So now we will be discussing the radiation phenomena and how it can be compared to an black body radiation, and we'll see what is the nature or the characteristics of black body radiation. Okay. So, in terms of defining a black body, what do you understand by a black body?
An ideal body that can absorb any radiation without albedo.
The presence of carbon in it.
Presence of carbon.
Yes, sir.
Sir, it
Huh?
can absorb heat,
So
temperature,
absorbent.
light. It can absorb everything. You can
It
say
can
that.
absorb any radiation. It's not only heat. So any radiation falls on it, so it can absorb. So by absorbing it, it goes to higher temperature. Okay, and after achieving the high temperature, then it starts to emit. So a black body is a perfect emitter, a perfect absorber. At least at the same time, it's a perfect emitter. So do we have any black body in real world?
No, sir. Ideal black body, I don't think we have.
Okay, or any far away from us, like any
Sir, black hole,
Black hole,
maybe.
sir.
black hole is there. Yes,
Yes,
black
sir.
hole is, you can compare black hole to a black body. Yeah. So physics in general, physics and astrophysics is one of the interesting topic. So okay, anyway, so this semester you're learning physics, so it's a good thing. So we will compare this radiation phenomena from like comparing it to how the Earth radiation is happening, or you can say that how the black body radiation is happening. Okay, so and what are the laws that are being developed or developed to explain the black body radiation. So the first law is the Stefan Boltzmann law. It states the intensity of total radiation from a black body is proportional to the fourth power of its absolute temperature. Okay. So E is equals to A sigma and T to the power 4, where E stands for the rate of emission of radiant energy per unit area per unit time. A is the surface area of the object, so that is basically a black body object. T is the absolute temperature, at what temperature it is radiating, or the black body is at. Then the sigma is the Stefan Boltzmann constant. So E is, you can say that E is directly proportional to the e to the power 4. But black body radiation is mainly in 19th century it was a big discussion. So there are many theories were developed to explain the black body radiation phenomena, but finally all the classical physics actually failed to explain the black body radiation. But finally, it could explain by the Planck's quantum theory. Okay, so the graph what you are seeing here. Okay, so this is a plot between the wavelength in terms of spectral radiance or energy. Okay, now if you see the higher end of the wavelength. Okay, so so this graph is representing three different temperatures and their behavior or the energy with the wavelength behavior. So if you see the red line, okay, so that black body is at 3000 K, okay, and if you keep on increasing the black body's temperature and the radiation will shift towards lower wavelengths. So, for example, the green line, which is at 4000 K, the maximum of that radiation comes towards the visible range. And if you keep on increasing, so again, so that again towards the lower wavelength. Okay. So this phenomena was not explained by the classical theory. So if you see the classical theory graph, that is the black graph. So that means so if you keep on increasing the temperature of a black body, the radiation would be like the energy or the radiation energy or the wavelength associated with this energy would be will not meet. So it is or would be more in the range of like UV visible range, more towards the UV range. So in another way, it was termed as like UV catastrophe. Okay, so if you see the classical theory explanation, but this theory was or the radiation phenomena was explained by the Planck's quantum theory. So where you see that after achieving a maxima, particularly for 5000 K, then it slowly decreases. Okay, even if you increase the temperature of the black body, the radiation or the wavelength associated with the radiation will not be go towards the UV range, but it will be still more or less in the range of visible range or close to the or very near to the UV visible range. Okay, now this type of curve is explained by the Planck's quantum theory because in that equation there are two exponential terms. So one term could explain the maximum in the first range, so from 0 to 0.5. The second exponential term is more dominant. There you see the decrease of the wavelength or the radiation and the energy associated with the wavelength is decreasing with the wavelength. So this is later explained by the Planck's quantum theory. Okay. So what we can take here that the wavelength and the absolute temperature lambda t max, okay, or lambda max t is a constant, okay, and this comes from Wien's displacement law. Okay, so before Planck's, so Wien's was able to explain the radiation phenomena from hotter body, okay, but it could not explain the whole diagram, okay, why it was decreasing or why it was more uh, low or the radiation associated with the wavelength is low at higher wavelengths or in the far infrared region. Okay, so that is beyond the UV visible range. Okay, but later the physics or the modern physics could explain this black body radiation phenomena. It was a big achievement during that time actually. Okay. Now next in this introduction topic is about the chemical composition of a lithosphere. So I will not go into the details of these things because these are some data which you can learn from book or already been discussed in your plus two or matric level. So I'll just skip this portion and we directly go to the first unit where we will be discussing the air pollution. Okay. Just so all of you can see the screen now.
No, sir.
No, sir.
No.
The
Sir.
screen sharing stopped, sir.
No, sir.
You are sharing your entire screen. Can you see now?
Yes,
No.
yes,
Yes,
sir.
sir. Now we can see.
Yes, sir.
Yes, sir.
Okay. So we will start with this problem. The problem is our air pollution. Okay. So here we'll be discussing what are the different types of air pollutants. Then we will see that what are the global phenomena or due associated with this air pollution. And finally, we will see that what are the methods or the current technology we are using to tackle these issues. So first is the air pollution. So what do you understand by air pollution? So air pollution may be described as the contamination of the atmosphere by gaseous, liquid, or solid waste. So it can be any form, physical form. So it can be a gaseous pollutant, can be a liquid pollutant, or can be a solid waste, or byproducts of that.
Sir, you are inaudible.
I'm not audible.
Yes, sir.
You are audible, sir.
You are audible,
Yes,
sir.
sir.
You are audible.
Yeah, maybe some of you are not able to.
No, sir. Actually, the screen suddenly became blank.
Just okay. Can you see the presentation now?
Yes, sir. It's clearly visible.
Right. Okay now.
Yes, sir.
Yes, sir. It's visible, sir.
Okay. Now, so this air pollutants can be a gaseous form, can be liquid form, or can be a solid waste. Okay, or maybe the byproducts. Okay. So if they are not, or they are harmful to human health or human plants or animals or attack materials, means if it's corrosive in nature, that is also an air pollutant, or if it's reducing visibility or producing any undesirable odors, so we can say that those type of substances are the air pollutants. So in terms of classification, we can classify uh, pollutants in two categories, that is the primary air pollutants, and the second one is the secondary air pollutants. So in primary air pollutants is those pollutants which emitted directly to the air, okay, from the source. Okay. And the examples are the carbon monoxides, nitrogen oxides, sulfur oxides, hydrocarbons, particulates, dust particles. So these are primary pollutants. So they emitted directly into air. Okay. Now, what are the secondary air pollutants? So these are the chemicals formed through the reaction in the atmosphere. Okay. And what is their sources? The sources can be the primary pollutants. Okay. So, for example, the secondary pollutants are the sulfur oxides, particularly SO3, ozone, nitric acid, sulfuric acid, sulfates, nitrates, all the salts. Okay, so these are the secondary pollutants, and what is the source for that? The source for those are the primary pollutants. Okay, So, for example, the nitric acid is basically the nitrogen oxides are the primary source. Similarly, the sulfates and sulfuric acids. So, the primary pollutants are the sulfur oxides. Okay. So, we will be discussing one by one. So, first we will discuss the carbon monoxide. Okay. So, carbon monoxide is a colorless, odorless, and tasteless gas. So, and it's 96.5% as heavy as air. It is not soluble in water, and its TLV limit is 50 ppm. Okay. So, what do you understand by TLV? Here, anyone?
No, sir.
No. Threshold limit value. Okay, what does that mean? That means that when we are exposed to carbon monoxide gas, okay, so we can take up to 50 ppm. So anything more than that would be harmful. Okay. So for each toxic gases, we have a threshold limit. Okay. Similarly, for nitrogen oxide, the threshold limit is 25 ppm. Okay. So anything up to 25 ppm is okay. Particularly, these are being standardized in order to work in an industrial environment, so where there is a possibility of exposure of human beings to different types of toxic gases. So let's say if it's carbon monoxide, so they have said, or the industry wise it's standardized that up to 50 ppm one can take. Okay, so anything more than that, you'll start to have different types of problems. So we'll see that what type of problems we will have. But first is how this carbon monoxide formation happens. Okay. So the carbon monoxide formation happens due to the incomplete combustion of fuel or carbon containing materials. Okay. So incomplete combustion means, so basically it's a burning. So burning means reaction with oxygen. So when carbon is reacting with oxygen, so that gives you carbon monoxide. Okay. So basically the carbon and oxygen gives you carbon dioxide. But if there is an incomplete combustion, okay, if the combustion is not complete, because first the formation would be the carbon monoxide. Then carbon dioxide also can react with carbon material to give you carbon monoxide. Dissociation of carbon dioxide may happen also at high temperature, particularly in case of lightning. So that is also one kind of source for carbon monoxide. The CO2 can be decomposed at high temperature to give you carbon monoxide and the oxygen. So these are the three different ways how the carbon monoxide is basically formed in our atmosphere. But mainly the contribution is coming from the incomplete combustion of fuel. So that is basically the transportation system. So if you see in terms of source, so we can divide that in natural source and anthropogenic, that is the man-made. So in terms of natural source, there are volcanic action, natural gas emission, electric discharge during storm, mass gas production, seed germination. So these natural processes also produce carbon monoxide. And in terms of man-made or anthropogenic, so the transportation contributes almost 64%, forest fire almost 17%, industries almost 10%. And what type of industries? Iron and steel industries, paper and petroleum industries. Also, to some extent, the agriculture activities also contributes to the carbon monoxide formation, particularly after the harvesting of our crop. So when you go for agricultural burning, that also contributes almost 9% or 8.3%. So what type of agricultural burning? The forest debris, crop residues, weeds, and other vegetation. Okay, so they also contribute for the formation of carbon monoxide. But overall, if you see, it is the transportation, or you can see that the natural or the use of natural petroleum gases is the main reason for the carbon monoxide released to the atmosphere. So So, so in some pictures you see that there is some volcanic action, there's some forest fire, then also due to the transportation you see, and due to the industrial activities, So these are the main sources for the carbon monoxide gas formation. Now, once you have carbon monoxide gas in your atmosphere, so what are the natural sources it can be consumed? So the major consumption or major sink is some soil microorganisms. So that basically includes the penicillium and aspergillus. So CO can be naturally consumed by these two microorganisms. And in terms of effect, it doesn't give any direct threat to plants, but it is very poisonous to animals and human beings. And what is the biological reaction? If you see that the carbon monoxide gas replaces the oxygen from the hemoglobin, because hemoglobin is the oxygen carrier in the body. So the oxygen supply inside the body is done by the hemoglobin. If that is replaced by carbon monoxide, so obviously the oxygen can't reach to the different parts of the body. So all the biological reactions will be hampered. And if you see in terms of reaction, so the reaction is more favorable in forward direction. That means that if the replacement of oxygen happened with the hemoglobin, then it's difficult to reverse that situation. So what happened? So over the time, when you expose to carbon monoxide gas, so you'll feel different types of symptoms. Okay. So what are the symptoms you see? So if you're exposed up to 35 ppm, okay, so mild headache is possible. Okay. Anything more than that, you feel nausea. Anything more than that, you feel dizziness. Okay. And if you go up to almost 3200 ppm, the breathlessness starts. Okay. And finally, you collapse. And anything, if you're exposed to 6400 ppm, then loss of consciousness may happen. And finally, a person may die. So these kind of cases does happen in our society. You might have heard about, or you might have come across different types of news that due to the
Hello, sir.
So, so your mic is off, sir.
Sir, your mic is off, sir.
yeah. Can you hear me now?
Yeah,
Yes,
sir.
sir.
Now it's
Sir, the
audible.
presentation has stopped, sir. We can't see the
Yeah,
present.
yeah. Actually, it stopped because my laptop is out of charge completely. Anyway, what I was discussing about the carbon monoxide. So, like overexposure of carbon monoxide finally leads to death. Okay. So, and this happens. This happens in our society. You might have noticed in some news channel that some people died in a closed room. And what was the situation? The situation was a generator was running inside that room throughout the night. Okay. So what happens when you're using a petroleum-based instruments? Okay, and and if you keep that instrument inside the room in a closed room, so over the time, what happens? The carbon monoxide or the concentration of carbon monoxide or the accumulation of carbon monoxide happens during over the hours. Okay, and if it's happening in the closed room, then obviously the concentration increases, and if it's somehow taken by the human being, then unconsciously, okay, so at the end the person may die, and it is happening in many cases. It happened. So what things we can take that if you're using any generator, so the first rule is do not run that generator inside a closed room, because even if you go to any functions where the generators are being used, particularly the petroleum based, you may feel very awkward when you are very close to that instrument. Okay, first thing is the carbon dioxide release. At the same time, if you have any incomplete combustion of petroleum substances, you may get some carbon monoxide gases. But that is if it's happening in a open environment, that is fine. But particularly, it's very lethal if it is happening in a closed inside room. Similarly, if you have any faulty AC, okay, or air conditioner, so that is also one reason for the generation of carbon monoxide. So it is highly recommended that do not run any faulty AC or air condition in a in that, because every time you will be accumulating this carbon monoxide gas, and the exposure of carbon monoxide gas leads to different types of health problems. And finally, if you are exposed for very long hours, okay, particularly 5-6 hours in a closed room, so it can be very fatal. Okay, so this is the carbon monoxide gas. So uh, or you can say that one of the air pollutants which we are releasing to the environment due to our activities, different activities, uh, different type of home activities, as well as different types of uh, industrial activities, and also due to the transportation system. So that is the main reason why we are moving towards the EV vehicles. Okay, and also time to time, the government is also declaring different types of um, uh, environmental pollution policies, like you have to use BS6, BS4, these type of environmental policies, just to reduce releasing of different toxic gases to the environment. So, okay. So the next would be the nitrogen oxides. So, but we may stop. I may stop it here. So the next is, I can share this with you. Just a moment. Or maybe discuss for 5-10 minutes. Then we can stop. Can you hear me now, students?
Yes, sir.
Yes, sir.
Yes, sir.
Sorry for the disturbance, actually. Mm, okay. Okay. So the next is nitrogen oxide. So NOx, that means we are not dealing with any one type of nitrogen oxide. So there are different types of nitrogen oxides. So one is NO, that is nitric oxide. One is NO2, that is nitrogen dioxide. We have also nitrogen pentoxide, that is the secondary type of pollutants. And the characteristics of nitric oxide, it's a colorless and odorless gas, while your nitrogen dioxide, NO2, is a reddish brown color gas. So in terms of PLV, for this particular oxide, so it is 25 ppm. And how this is being produced in our atmosphere, so one is the transportation, the other one is the high temperature phenomena or high temperature reaction. So at 1500 degrees centigrade, when nitrogen is exposed to oxygen, so nitric oxide formation happens. Once you have nitrogen oxide, so that again may react with oxygen to give you nitrogen dioxide or NO2. Okay, and that happens around 1100 degrees centigrade. Anyway, so this type of temperature is not a common day phenomena. So maybe the in terms of natural sources, for example, the lightning phenomena may reach this kind of temperature. Also, we may go to this temperature in case of the metal extraction processes. Okay. So when we extract metal from the oxides, so we go to very high temperature for different metals. So maybe uh, in that environment, industrial environment, you may have formation of this kind of nitrogen oxides. So in terms of different types of sources, uh, the natural source is bacterial action. Then the lightning phenomena is also responsible for the production of the formation of nitrogen oxides. And in terms of man-made, it is basically the combustion of coal, natural gas, or gasoline. And again, so in terms of contribution from the transportation is almost 50%, and other 50% includes basically the power plants, the industries, the domestic and commercial heating plants. So they also contribute almost the formation of nitrogen oxides. Now, what is the natural source for the sinkage? So the natural process including the photochemical reaction, which take gas of nitrogen oxides in the atmosphere, forming nitric acid as the end product. Okay, so which is also the part of your acid rain. Okay, one of the component from the acid rain, and also it doesn't stop there. Yes, yes, Bivas, what is your question?
Oh, sorry, sir.
Okay, okay. So, once you have this nitric acid, so again, they may give you this nitrate salts, and these salts are also soluble in water, and they form this particulates. Okay. So, the secondary type of air pollutants. Okay, and the basic reaction, if you see, the nitrogen dioxide is in presence of O3 or ozogen that gives you the nitrogen dioxide plus O2. This reaction, so this is also responsible for the removal of O3. So the nitrogen oxide is responsible for the removal of O3 from the stratosphere region, and the basic reaction is this one. So the O3 is reacting with NO2 to gives you NO3 plus O2. Then NO3 and NO2 can give you the nitrogen pentoxide, and in presence of water, the nitrogen pentoxide give you this as HNO3, and that comes to the earth in form of acid rain. And also this HNO3 can also give you different types of nitrate salts, and these are water soluble. So with the water particulates or water vapor, they form these particulates which are secondary pollutants. Now, what are the effects the nitrogen oxides does? So one is it's consuming the ozone layer in the atmosphere, and it also
Hello, sir.
Sir, you are not audible.
I think sir got disconnected.
No, no, sir is there, right? I think.
लैपटॉप डिस्चार्ज हो गया
हाँ शायद हुआ होगा.
लैपटॉप डिस्चार्ज हो गया, वो 2 मिनट बीच में रहते हैं,
मोबाइल
पता
पे
नहीं
है
क्यों.
वो
Let us wait. Sir will come.
Hello, Sahu.
Sir is totally disconnected.
अरे हाँ भाई, बोल तो रहे हैं सर चलेगा।
तो सर है ही नहीं बिल्कुल मीट में।
अरे तो हम क्या बोल रहे हैं?
अरे कम से कम सर का अकाउंट तब दिख तो रहा था, अब तो दिख भी नहीं रहा।
अरे वो क्या होता है ना, जब
तो
चार्ज
धीरे
खत्म
धीरे
हो 2 मिनट
प्रस्थान
तक
करें क्या?
मीट में रहो। मैसेज
हाँ, वो
करेगा।
डिस्कनेक्ट होने में कुछ समय के लिए वो रह जाता
अरे
है,
अब
पता है।
धीरे धीरे प्रस्थान करें यहाँ से।
मत
देखो
कर
सर,
भाई, अभी भी
क्विज
नहीं
के लिए
नहीं,
भेज
अरे
रहे हैं।
क्विज के
क्विज
बारे
वाले
में
बाकी है।
बताएंगे, क्या प्रस्थान कर रहा है भाई।
पर बोले तो
हाँ
क्विज
भाई,
लिंक भेजेंगे।
5:30 बजे क्विज।
आ गया सर।
सर आ गए सर आ गए।
Who says no quiz? There will be quiz. The content for the quiz would be from where we.
ग्रीन
Okay,
हाउस सर।
so the air pollution part up to the nitrogen, and the portion from that, the last portion, that is the black body radiation. Okay,
Yes sir.
and let me share this in the drive as well as
Sir, will you have
in,
the PPT slides to us?
I'm sharing this. I'm sharing this one. Just a
Okay
moment.
sir.
Sir, at what time we'll have the quiz?
Again, exactly at 5:30. So you have half an hour to go. So you can have a look during
Sir,
the
can you
time.
again tell what are the things that will?
I'm sending it in the group also. Do you need it in WhatsApp group?
Anywhere sir, anywhere. Where you want to share
I
it?
सर क्लासरूम में भेज दीजिए।
Sir,
I have already
classroom
put
will
that
be
in the I've already put that in the drive folder. But also
Yes.
I'm putting a link there also so that you can just click it there and you can get it.
Okay sir.
सर टाइम लिमिट 20 मिनट से होंगे।
20 minutes, only 20 minutes. Okay, so I put that in the drive folder directly the PDF file. Yeah.
Yes sir, it got that.
Okay. Okay. So anything you want to discuss or just take half an hour to read these two materials? Okay.
Sir,
Yes.
so what about Planck's quantum theory? You also have taught that this
For that,
phases.
for the quiz.
Yes, sir.
No, no, it's just very simple question will be from there. No, 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 no physics, no physics.
Okay, sir.
Sir, in that PDF you have sent only one PDF, no sir, air pollution PDF.
Yeah, that is air pollution and the previous PDF you have from the first
Yeah,
EVs
yeah,
Lab.
yes sir, yes sir, yes.
A very simple question from that portion.
Okay sir.
Okay.
When we leave sir?
Yes, if you want to discuss, I'm here, or else you can leave and prepare. And exactly at 5:30, you'll get the link in the classroom. Okay.
Okay sir. Thank you sir.
Thank you,
And
sir.
in
Okay, sir.
terms
Thank you,
of
sir.
declaring the result of quizzes, so after three quizzes, you'll get the results. Okay, all the three quizzes.
Thank you sir.
Okay,
Okay sir.
सर द
Okay, sir.
पीरियड ऑफ 20 मिनट्स ना।
20 minutes exactly. It will start at 5:30, and the quiz form will automatically close down at exactly 5:50. Okay.
ओके सर।
Thank you sir.
Yeah.